Okay, you are welcome back to Introductory Mathematical Analysis B. Okay, now we are in 12.5, and in 12.5 we are dealing with logarithm differentiation. Okay, this is different from the derivative of logarithm function. This is different. So when you are given y equals to ln x, then you say the derivative is 1 over x. Or when you are given y equals to log base 2 of maybe s squared, then before you can derive this, you can rewrite this as ln s squared all over ln 2. And when you want to derive it, then you say 1 over ln 2, because 1 over ln 2 is a constant, then 1 over s squared multiplied by 2x. Okay, which will now give us 2 all over ln 2x. Okay, so this is the derivative of log. Okay, derivative of logarithm function. Okay, now here we are dealing with logarithm differentiation, where we first apply logarithm, take the logarithm of both sides before we derive. We take the logarithm of both sides before we derive. So when we are talking about logarithm differentiation, we take these following steps. So given y equals to f of x, so we take the following step. The step number 1 is that we take the natural log of both sides. Take the natural log. Natural log is the ln. Okay, take the natural log of both sides. That is the first step. The second step is that you simplify ln of f of x. Okay, when you take the natural log of both sides, then we have ln of y, and then we have ln of this. So you now simplify this other side, which is the right hand side, which is the right hand side. Okay, you simplified ln of this, which is the right hand side, using the properties of logarithm, using the properties of using the property of logarithm. Now the step number 3 is that you now actually find the derivative, then you differentiate. After you simplify that using the property of logarithm, then you differentiate both sides. With respect to x. Okay, and then number 4, you now solve for the y over the x. That means you make the y over the x the subject. Okay, and then number 5, you need to now express your answer. Express the answer in terms of x only. Express the answer in terms of x only. Okay, so those are the steps you need to take. Number 1, take the natural logarithm ln of both sides. Simplify the right hand side using the properties of logarithms. Differentiate both sides with respect to x. Then solve for the y over the x, and then express the answer in terms of x. Okay, we are going to take an example for you to understand what we're doing. Okay, we take a simple example first. Let's take a simple example. Then we now do maybe a little more complicated one. If y equals to 2x minus 5 raised to power 3 all over x raised to power 2. Okay, find the y over the x using logarithm differentiation. Okay, so we want to use logarithm differentiation. Of course, quotient rule can be used on this, but we want to use logarithm differentiation for this. Okay, so what is the first step in logarithm differentiation? We take the log, the ln of both sides, the natural log of both sides. So that will be taking the ln of both sides. We have ln y equals to ln of this whole thing there. Okay, so we are taking the ln of both sides now. Now, what is the next thing to do? The next thing is to simplify this right-hand side using the properties of logarithm. Okay, if I want to simplify, log is on both of these, so I need to have this first and then separate it with this, but because this is a division, then it becomes negative. It becomes a difference. Okay, we are still simplifying. You must make sure that you simplify to the lowest one. In logarithm, when we have a power, we can bring it down. So we can have 3 ln 2x minus 2 ln x. Okay, any other simplification? There's no other one. So this is still ln of our y. Okay, now with that, now we can now differentiate. So after we simplify, then we can differentiate. Okay, let me write out this. So I have ln y equals to 3 ln 2x minus 5 minus 2 ln x. Okay, now I differentiate. When I differentiate this, I'm going to have 1 over y. But don't forget we are differentiating y, so we need to multiply it by the y over the x. When I differentiate this, I will have 3 over 2x minus 5, then multiply by the derivative of inside, which is 2. Okay. Minus, when I differentiate this, I have 1 over x, then multiply, okay, by 2, because 2 is already out. Of course, multiply by 1. Okay, so this will be 1 over y, dy over the x, equals to, this is 6 over 2x minus 5, minus, this is 2 over x. Okay, so now we need to make dy over the x the subject. So that means I need to multiply both sides by 1 by y. Then it will become dy over the x, which will now be 6 over 2x minus 2 over x multiplied by y, because I want dy to be the subject here. Okay, so we are not done here. Okay, we are almost done, but not done, because now this is y here. We need to express it in terms of x, everything on this side. So what is y initially? Y, this is y given to us initially. So we replace the y by that. So we're going to be having equals to, so this derivative equals to 6 over 2x minus 5 minus 2 over x, then multiply by the value of our y, and what is that one now? That is 2x minus 5 raised to power 3 all over s squared. That is the value of our y. So we need to replace it with that. So that is the end of it, but let's write it out nicely. So our dy over the x that we got is 6 over 2x minus y minus 5 minus 2 over x, then multiply by 2x minus 5 raised to power 3 x raised to power 2. Okay, that is our answer. Okay, that's our answer. So that is how to use logarithm differentiation. Okay, I take one more example of that. Another example. Okay, differentiate y equals to x raised to power x. Okay, using logarithm differentiation. Okay, all right, so let's go again. What do we need to do? We take the ln of both sides. Ln of y equals to ln of x raised to power x. Okay, that is fine. So the next thing is that we must simplify the right hand side. So with this, we can bring this down to become ln of x. All right, any other simplification? No. So now we need to derive. We need to derive. To derive, this becomes 1 over y, then the y over the x. To derive this is a product rule. So hold on to x, differentiate this, plus hold on to this, differentiate x. 1. Okay. All right. So with that now, we have 1 over this, the y over the x equals, so this becomes 1 plus ln of x. Okay, that's what we have. Now you need to make the y over the x the subject by multiplying both sides by y. So the y over the x is now equals to 1 plus ln of x multiplied by y. Okay, but don't forget what we have as y before. So we need to replace it by what we have as y, x raised to power x. That's what we have as y. So we now have 1 plus ln of x multiplied by x raised to power x. Okay, now that is our answer. Okay, please ensure that you understand. Ensure you understand.